what hyperconverged infrastructure actually is. But just know that hyperconverged is really changing and transforming the way that organizations process and store very rapidly increasing amounts of data. And Pivot 3 actually started around 2003 by solving some big, major, new emerging challenges around a single use case of video surveillance. And since that time, we've become really leaders in the broader world of data center infrastructure, but we continue to remain leaders and committed to the video surveillance solutions as well. So that's what we're going to focus on today. That's what we're going to talk a little bit more as we go through the presentation today. Our overall learning objectives, we're going to talk a little bit about what some of the major trends in video surveillance are, some of the new ways that we're seeing enhanced value from video surveillance, new ways to use video surveillance to deliver different types of value to your organization. And then we're going to look at what are some of the implications on your infrastructure, your servers, your storage, your networking, that is being driven by some of these changes in video surveillance technology. And if we're also going to look at what are the various alternatives you have for different types of infrastructure solutions and technologies. And then we'll wrap up at the end with a brief look at the Pivot 3 technologies and solutions that we have specifically focused around video surveillance. Now, as we mentioned before, if you have questions throughout this, please enter them into the question box, and we will try to address those towards the end of the presentation today. Okay, let's first start out talking about and looking at the additional and the new and enhanced value that video surveillance can deliver to organizations today. Now, if we sort of take a look back into history and look back at where video came from, the old days of analog video surveillance technology with black and white images, typically then video surveillance was really only used as a tool to catch the bad guy. If something bad happened, we hoped that we got an image of that happening on video, and maybe we could go catch that person and perhaps recover whatever loss that was. And then to a lesser extent, video was used as a deterrent to prevent criminal or other types of incidents from happening, although I think that the usage there could be considered a little bit questionable. But now, as video surveillance technology has advanced substantially, we're seeing that it can be used much more proactively, both as a security tool to identify and prevent perhaps incidents from happening in the first place, as well as a tool that organizations can use to ensure better operational or business continuity and even some cases business intelligence. When you think about the security uses for video surveillance today, talk to any type of security or law enforcement officer, they will tell you that accurate and fast detection and response to incidents is the best way to mitigate or to reduce the impact of that incident happening. And now we can use technologies like video analytics to help us detect events, sometimes in real time or in some cases even before they start to happen. We can use mobile technologies now to better arm or to better equip our responders to respond to incidents very quickly and mitigate their impact of them. We're seeing obviously things like body-worn cameras being used by law enforcement officers to improve public safety and also to reduce liabilities, both for the public as well as for the departments and the agencies themselves. And we're seeing applications like in casinos or in manufacturing operations where video is being used to ensure ongoing business continuity. We're also seeing video used in retail environments and again in manufacturing operations and even in office environments to improve business intelligence, to understand what's happening in our business and how can we make things work better and how can we make them more efficient. So we're using video for all kinds of different purposes, all kinds of different reasons. Now at the same time, the underlying technology, particularly around cameras, is changing rapidly. We're seeing higher and higher resolution cameras come out. Now, not long ago, just a couple of years ago, the average resolution of a video surveillance camera would have been considered VGA, or what we call standard definition resolution today. So think about your old big tube televisions and what that image used to look like. And then over a couple of years, we've seen that resolution, that image clarity improve rapidly. Now we're up to 4K and even 8K cameras, which, to put that into context, is an 8K camera might be a 30 or 35 megapixel type of video camera, so very, very high resolution. We're seeing the need for longer and longer retention times for that video, so how long do we store that video after it's been captured? And we're seeing the prices of these cameras come down, so for relatively fixed budgets, we're seeing more and more of these cameras being deployed at higher and higher resolutions for more and more use cases. Well, the impact or the result of all this is we're seeing just an explosion in the amount of data being generated by video surveillance. In fact, there's an analyst firm called IHS that's put out a forecast here that said next year, in 2017, we expect video surveillance systems to generate just over 1,500 petabytes of new data every single day. Now, to put that in context, that's about 3 times as much data as was being generated in 2014. So the amount of data from video surveillance is doubling roughly every 18 months right now, which is a pretty staggering rate. There's another data point out there that has said that 50% of the data that's produced by the Internet of Things will come from video surveillance in 2020. So just really to drive home the point, we're seeing lots of new data being generated, and that data is much more important to us than ever before. As a result, it's creating new pressures in our organizations. We'll talk for a second about where that's coming from. So virtually every organization, whether it's a business, the private sector, or a government organization, or a school, or an institution, whatever it might be, virtually every type of organization has a security function, whether that's a dedicated department or somebody that is just accountable for security. And that function is responsible for protecting the organization from liabilities, reducing risk, and protecting against operational continuity or any type of interference to ongoing operations. Now, because of that, and because of all the data that's being generated before, suddenly no longer can we tolerate things like data loss, like system downtime, or the inability to access either live or recorded video. However, we're actually more vulnerable to those types of interruptions or those types of failures than we ever have been before. And those types of failures can actually work backwards against us and can lead to increased liabilities and increased risk, or potentially even interrupt our operations. So as a result of that, now we are putting more and more pressure on either our IT departments or our systems integrators or somebody to deliver solutions, to deliver systems and infrastructure that provides the highest level of performance, the highest level of resiliency, and of course does so in a way that stays within the typical constraints of a security budget and the amount of money and finances that we have available to deploy this technology. So let's talk for a second about why performance and resiliency are so important to us. Oftentimes, particularly if I'm talking to an IT department and we talk about managing video surveillance data, people often come back to me and say, we'll handle our video data the same way that we handle every other piece of data in our organization. And what I typically say to them is that you can't do that because video surveillance is actually very, very different than virtually any other type of application that you have inside of your organization. First of all, it's very bandwidth and CPU intensive. Anyone with a mobile device or anyone that's tried to stream video over the internet or on demand or something like that knows how bandwidth intensive video surveillance is. Video is also, though, very write intensive. Now what I mean by that is if you take a look at the typical IT application or the typical IT workload, the general rule of thumb is that about 20% of the time data is being written to a disk, and about 80% of the time that data is being read back. And as a result of that, most server and storage infrastructure is really optimized for that type of ratio. Well, video surveillance is really the exact opposite of that. Video surveillance is more like 95 to 99% of the time we're writing data to a disk. And in addition to that, video surveillance data is typically highly variable. Now what this little squiggly line that I'm showing you represents is the typical amount of data that's generated by a video surveillance camera at any one point in time. What you'll notice is that it typically hovers around some low level most of the time if it's just staring at an empty hallway or an empty parking lot where nothing's happening. But then you start to see these spikes in data, and those spikes can be caused by activity or motion within the scene, within the field of view. Could be caused by alarm conditions, could be caused by a number of things, but those spikes tend to be significant. They tend to jump up pretty high. In fact, they can increase the amount of data generated by the camera by orders of magnitude instantly. Now most IT people would say, well, we can handle those data spikes pretty easily. That's not a really big deal for us. Well, that's probably true. However, if you consider that this exact scenario may be replicated across dozens or hundreds or even thousands of cameras simultaneously, very quickly what can happen is the amount of data that's being generated can overtake or can become too much for the storage system to actually handle. Remember, those storage systems are optimized for that 20% write, 80% read type of ratio. Well, when that scenario happens, it results in data loss. Okay, and once again, we have to understand why data loss is important when it comes to video surveillance. A lot of people say, well, my video cameras generate 30 frames per second of video. What's the big deal if I drop a couple of frames here and there? It's actually, believe it or not, it's a really big deal. When data is lost, or what we call frames are dropped, one of two things can happen. Number one, we can degrade the quality of the image that we're seeing. And I'm showing an example of it here. When frames start to drop, what you start to see is that pixelation or that fractalization that you see in images. Well, that's a really big deal. Organizations invest lots and lots of money in high-resolution, high-definition, multi-megapixel cameras so that they get a very clear image and they can positively identify what's happening on the screen. If the image is degraded, then that video is no good to me at all. Right? That video, then suddenly I'm not getting my return on the investment that I made in video surveillance. The other thing that can happen as we lose frames is we can actually lose entire segments of video. Okay, and the bad part about this, not only is that we're losing it or that the image becomes degraded, is that we don't even know that this is actually happening until we go back and try to review that recorded video in the past. So these are some really, really bad things that happen when your system can't perform well enough to take in or to what we call ingest all of that video data that's being generated at any one point in time. The next is about resiliency. Now when I say resiliency, I mean ensuring that our systems are online and always operating, and that we always have access to both live video as well as we're always recording, and that all of our previously recorded video remains safely and adequately protected. Now once again, most IT departments will come to us and say, we have tons of tools for resiliency. We have replication and backups and snapshots and even RAID and high availability. We have all kinds of great solutions to drive resiliency. Well, problem is that most of these either do not work for video surveillance, or they can be prohibitively expensive. For example, we can't do snapshots for video. We can't back up video data. We can do replication for video, but it's extremely expensive and inefficient to do. And even traditional solutions like RAID really don't work very well for video surveillance at all. So we have some real challenges around both performance and resiliency. So I want to take just a minute now and look at the various alternatives you have for server and storage infrastructure for video surveillance, and then, like I said, I'll compare these to what Pivot 3 does in just a few minutes. Now, the vast majority of video, at least in North America today, is deployed on what we call direct attached storage. Most people know this as an NVR, or a network video recorder. Now, an NVR works typically pretty well and is really designed to work for smaller systems. So think less than 20 or maybe 30 cameras or so, somewhere in that range. But as these systems grow, oh, and by the way, NVRs were actually designed to mimic the functionality and the experience of a VCR, back in the old analog days of a VCR. But as our systems grow larger and as the amount of data we're generating gets more and more, NVRs have some real challenges associated with them. The first and foremost, and probably the most important here, is that they're prone to single points of failure. Okay, so one of these NVRs goes bad, or if a drive goes down, then we're suddenly looking at substantial downtime. We're looking at potential for, in some cases, catastrophic data loss, inability to access live or recorded video, and these are all things that we just talked about our customers, our end users can no longer tolerate. But also, as these systems get bigger, you'll notice this, which represented by those cylinders on the right-hand side of the screen, this very inconsistent retention time. And this is caused by these, what we call these stranded islands of storage, or stranded islands of capacity that happens across all of these different recorders that are just sitting up next to each other. You know, we never really know where the video data is going to come from at any one point in time. So as these systems get very big and we put multiple NVRs next to each other, either one or two things has to happen. Number one is that some NVRs are using all of their storage and unable to keep up with the required retention time. Or number two is we have to overbuy. We have to buy way more storage than what we had originally planned for in order to ensure that we're really adequately capturing all of the video that we wanted to. And this can be a very, very difficult thing to manage as these systems get larger and larger. Now, moving on from direct attached storage, we look at the other end of the spectrum, which is shared storage solutions. And really, quite frankly, the IT world moved away from direct attached storage for the most part many decades ago, and is really focused on this type of architecture now, where we have the separate servers, either physical or virtualized servers, and they're all accessing a common pool of shared storage called a SAN, or in some cases a NAS. That would be a storage area network or a network attached storage type solution. And this type of architecture can solve a lot of the challenges that we see with NVRs and direct attached storage. However, SANs and NAS storage solutions were really designed for general purpose IT applications. They were designed for that 20% write, 80% read type of application that I talked about before. And as a result of that, they tend to perform very, very poorly for a write-intensive application like video surveillance. When they perform poorly, that leads to the challenges I showed you earlier around video loss, around image quality degradation. Well, the other thing about SANs and virtualized server infrastructures is that they tend to be very expensive, and they tend to be built on big, very complex, very proprietary hardware that requires dedicated teams of highly trained and highly paid people to manage on a day-in, day-out basis. And quite frankly, they can be difficult to scale. Now, some organizations have the resources to manage and deploy those types of solutions, and that's great. SANs can work very well. but remember, they tend to perform very poorly for video surveillance applications regardless. So let's talk about for a second what Pivot 3 has done to solve some of these challenges that we've seen, to help organizations manage and deal with the rapidly increasing amount of data that's being generated by video surveillance. We have come up with solutions that's called Hyperconverged infrastructure specifically optimized for video surveillance. Now, what the heck does that mean, right? Well, let's talk through it here. Basically, we are able to deliver all of the enterprise class value and capability that your separate SAN storage and virtualized server and even some elements of the storage networking, which those things can deliver. But we're able to eliminate the need for big, dedicated proprietary hardware and actually replicate all that functionality through software. And then what we do is we deliver that software on standard, off-the-shelf server hardware. In fact, the same server hardware that I talked about before that's used in the NVRs, or the direct attached storage. So what I'm representing here, that each one of those horizontal gray boxes would represent a piece of hardware, a server in this case. We typically deploy these servers in clusters, anywhere from 3 to 12 of these servers, or these nodes as we would call them, together in one cluster. And each one of those nodes has some special software on it that is really the magic that makes everything that I'm going to tell you about, really makes everything happen. So the software does a couple of things. First of all, it virtualizes all of the server applications represented by the VMs there, or the virtual machines. Now in our case, in the case of video surveillance, each one of those VM boxes would represent a recorder, a video recorder, just like an NVR, right? But we have the ability now to consolidate, in some cases, consolidate multiple recorders down onto fewer, smaller amount of hardware. And then secondly, we have our vStack software. That's Pivot 3 software. That's really the secret sauce that makes all of this work. vStack, by the way, stands for Virtual Storage and Compute. And it runs on all of the boxes, all of the nodes inside the cluster. It does a couple of things for us. First and foremost, it aggregates all of the storage resources from all of the boxes, and there's up to 16 hard drives in each one of those boxes, up to 128 terabytes of storage in each one. It aggregates them all together and pools them together into one common pool of shared storage that we call a virtual SAN. And then the vStack software actually functions as the storage controller and has some very special capabilities inside that optimizes it specifically for a write-intensive application like video surveillance. We also have some capability to drive some high levels of resiliency. Okay, so I'll talk in just a minute a little bit about how we accomplish all this, but first I just want to show you what the real value is that we deliver. First of all, we will deliver the highest levels of performance, meaning we'll be able to achieve high levels of data ingest. We're able to take in massive amounts of video without dropping frames. And that's the big value here. We'll do that and we'll sustain that performance even when we operate in what we call a degraded mode. So that's when things go bad, right? When hardware fails, when hard drives fail, when entire nodes fail, we will sustain that very high level of performance without interrupting the rest of the system there. Secondly, we'll deliver extreme levels of resiliency. So in our case, think 6 nines or 99.9999% system uptime and data availability. What that means is we eliminate all those things that we just talked about we can't tolerate anymore. We eliminate downtime, we eliminate data loss, and we ensure that both both live and recorded video are always available and always accessible even when things go badly. Okay, again, even when hardware fails and things go badly for us. And then lastly, we're highly scalable. We have the ability to start small and grow to effectively infinite scale in a very simple, a very cost-effective, in a what we call a non-disruptive manner, meaning we do not require that systems be taken down or offline in order to scale our systems out. So we deliver this, what I would consider enterprise class value, enterprise class functionality, but we do it without the typical complexity that comes along with our enterprise class infrastructure, without the need for real advanced IT skills to manage this stuff on a day in, day out basis. And we do it much more cost effectively, much more cost effectively. And in fact, I'm going to show you some numbers here in a few minutes that demonstrates this, the cost effective nature of this. So I want to spend just a minute here. I'm not going to go into a lot of technical detail. We're happy to have a more in-depth technical conversation with you offline if you're interested, but there are a couple of things here I want to point out, and I want to be sure that I think we're going to make these slides available to you after the presentation today, so I want to be sure that you have this information here. So I'm going to move relatively quickly through this part. I just want to touch on a couple of things here real quick. You'll notice each one of those chevrons represents one of the key value points that I mentioned earlier. Most storage systems that are positioned for video surveillance will tell you that they're quote-unquote optimized for video. And the reality is that the vast majority of them actually are not. Beyond perhaps using a special type of hard drive or something like that, they really don't do anything special for that video surveillance workload that I told you is so unique. Well, with Pivot 3, with our surveillance solutions, that's not true. We have real patented intellectual property that make our systems perform much, much better for a video surveillance workload. And I'm not going to go into the details of what those are. It has to do with a patented technology that we call scalar erasure coding and some other features and functionality of our software that enable us to work very, very efficiently inside of a virtualized environment, which most other video systems cannot do. On the resiliency side, I told you that we deliver 6 nines of uptime and data availability. Well, what that means is, the way that we do that is, one, we have built-in server failover directly into our system. So if one of our nodes fails, the virtual machines on that node will automatically move over and restart somewhere else in the cluster. Now, that's a core feature in our solution set. That's not an additional piece of software. That's not an additional license. You don't have to buy extra hardware for it. You don't have to spend more money to get it. It's just a core part of every piece of every node that we sell. Secondly is the way that we protect data once it has been stored. Most storage systems can protect data against the loss of either 1 or 2 hard drives failing simultaneously using RAID technology. We don't use RAID. Again, I mentioned we use something called erasure coding. And what that means to you is that we can protect data against up to 5 drives failing simultaneously. Or we can protect data against the loss of an entire node and all 16 hard drives inside of it, plus 2 additional drives somewhere else in the cluster. If all that fails simultaneously, not only is your data protected, but it remains instantly accessible. We don't have to wait for a rebuild to happen in order to access that data. So in a worst-case scenario, a node fails, just completely fails, just goes offline, the power cord gets pulled, just a total catastrophic failure of an entire box. 2 things happen. Number one, the virtual machines automatically move and restart somewhere else. That means that our video system stays online, that we have access to live video and we're still recording. And all of the data that's associated with that failed node is not only protected, but it remains instantly accessible. That gives us the ability to look at previously recorded video up to the moment of incident immediately without waiting for a system rebuild, which can take a very long amount of time. Okay, I talked about scalability a little bit already, but the fact that we are always online, automatically load balanced across, means that scaling our system is a very, very simple and very, very cost-effective thing to do. Simplicity, I mentioned, the way that we've designed a lot of the complexity out of our systems is that we've automated most of the daily management tasks and notification and activities required around managing and administering enterprise class infrastructure. So it can be done by somebody who doesn't necessarily need a very high level of advanced IT skills. And in a few minutes, I'm going to talk a little bit more about the cost effectiveness, but we deploy on standard, off-the-shelf x86 server hardware, non-proprietary, and some of the features of our system ensure that we can make available, we ensure that you can use a very large amount of the storage that you buy. Okay, we're very, very efficient in our storage utilization. So these are some of the things that kind of play into it. And as I said, we can go into more detail with you offline after the presentation here. I want to change gears for just a second. I've been talking about the servers and the storage side of video surveillance implementations. I want to talk for just a second about the client side. Okay, this is a typical SOC or a security operations center. This is where people sit in front of workstations and they look at the video every day, and they look at both live and recorded video, and they use that video for some purpose or another. We've actually developed some technology that delivers some real interesting innovation around the client side of applications. So what's happening here? Well, first of all, we know that we have some major trends that are influencing users' expectations. Right? Nowadays, we expect to be able to access information, whatever that information is, anywhere. We expect to be able to look at it on our mobile devices. We expect to be able to use our own mobile device. In fact, one of the big trends in many organizations is the BYOD, or bring your own device. So we're continually reliant on our mobile devices, not just in our personal lives, but also in our professional lives. Now, currently, our options for mobilizing video surveillance, and particularly other integrated systems like access control or visitor management or emergency communications or whatever other systems that may be tightly integrated with video surveillance, currently our options are very limited. Typically, I may have a mobile app from a video management software provider that I can look at one or two cameras or four cameras perhaps on, but it's a very bandwidth intensive application. It may or may not work very well. I certainly don't get access to my other integrated systems, and it's just a very limited type of experience. Typically, I don't have access to all the functionality that I would have if I were sitting inside of a security operations center or in front of a dedicated workstation with my full client software on it. So we have developed a solution called the Virtual Security Server that solves a number of these problems. Now, if any of you are familiar with a technology called virtual desktop infrastructure, which is becoming a very common type of technology or common type of application in the IT world, because it eliminates the need for dedicated workstations and can reduce organizations' costs pretty substantially. Our virtual security server is actually based on virtual desktop infrastructure technology. Now, what it does for us in the world of video surveillance and physical security is it enables us to deliver a fully functional, fully operational client experience to a mobile device or to any type of device as if you were sitting in front of a dedicated, expensive, graphics-enabled workstation inside of a security operations center. Now, one of the challenges, people will say, well, why don't we just use our regular, quote-unquote, regular VDI system to do video surveillance? Well, You can, but there's some real limitations to doing that as well. Typically, with most VDI solutions, if you put an intensive workload like video on there, you may get 1 or 2 streams of high definition, full frame rate video before that system just can no longer keep up. It can't perform anymore. We've solved that problem. We are able to deliver as many as 65 simultaneous high definition 1080p 30 frame per second video streams from a single box, from a single node of our virtual security server. That means we can deliver the full rich client experience, not only video, but all of our integrated systems. And we can deliver it to any type of device. Think about your mobile phone or your tablet, or something called a zero client, which is basically a small box that would replace a workstation for a fraction of the cost. And regardless of who the video surveillance or the access control system manufacturer is, this virtual security server will work with anyone's solutions as long as they run on a x86 processor, which 99% of them do. Now, we can deliver that out to any device, but we do so in a way that requires much less bandwidth than you would typically use with a full rich client application or a native application. So typically we'll see for sending, let's say, 8 or 10 or however many video streams you want to send out to that device, we'll see a reduction in bandwidth of about 50%, which is pretty substantial. And perhaps most importantly in all this, the data itself, the underlying video data that you're viewing on your mobile device or wherever you happen to be, remains secure. The data itself never actually leaves the data center. All of the processing, all of the decoding, all of the storage, everything that's done here happens on the virtual security server back in the data center, and the only thing that's transmitted out to the device is the image of the desktop itself. So that means we can deliver pretty sensitive video information, access control, other types of security information, not only to mobile devices, but to people like first responders, to remote guard shacks, to a security director's home, without being concerned about that data being downloaded or somehow accessed by an unauthorized person. So the benefits here for VSS, as we call the virtual security server, mobility. We can improve situational awareness and response by putting information into the hand of our first responders and the people that need it. Securing the data and reducing cost, eliminating the need for those big, expensive, graphics-enabled workstations, as well as lowering the total amount of bandwidth required. So the great thing about virtual security server is it can be used in conjunction with all of our server and storage solutions as well, and they all integrate together, they all work together seamlessly. Okay? So I want to talk for just a second now about the cost effectiveness. I told you about all this great value, enterprise class value that we deliver. You're probably sitting there thinking, gosh, this must be outrageously expensive. There's no way we can afford this. This is going to be terrible. Well, I want to hopefully dispel that a little bit here. So most of you are probably familiar with a firm called Forrester. They're one of the big IT analyst firms out there. They conducted what they call a total economic impact study on us recently. And what that means is they look at the 3-year total cost of ownership of Pivot 3 infrastructure versus traditional SAN storage and server infrastructure. And they're completely independent, third-party group. The only input they take from us is us explaining how our technology works. And they make all kinds of adjustments here in this. But I'll show you the numbers in just a second. What they do is they go out and they talk to a whole bunch of end users. They come up with this representative scenario. In this case, it was a system that has 2,000 cameras and 500 virtual desktops. So this is a mixed workload system where storage needs are growing and they're sort of running out of space inside of their data center. Now, The results of this are what's so interesting, and I'll point you to the bar charts there in the middle of the page. What you see there is those charts represent the 3-year total cost of ownership of traditional infrastructure on the left, and that's a combination, by the way, of hardware costs, labor costs, as well as any extraneous data center costs, versus Pivot 3 on the right. And what you'll notice there is Pivot 3 is just less than half, less than 50% of what it would typically cost you to deploy these types of systems in traditional infrastructure with traditional architecture. Now, beyond that, not only is it much lower cost, but it delivers over 100% ROI and has a payback period of roughly 7 months. Now, when this report was completed, which, by the way, we can make this full report available to you that has all the details in it and tells you how they calculated all of this. When they finished it, they looked at it, and Forrester came back to us and said these are some of the best results that they'd ever seen in a study like this. So we're very proud of this, and we know that we can deliver all of this enterprise-class capability and value without adding burdensome amounts of cost and complexity to your organization. So I'll wrap up here in just a minute, but I do want to talk about the fact that we are an infrastructure company, meaning we make the servers and the storage infrastructure that virtually all of the software and all of these other applications run on. And what that means is we are very, very open. We work with a vast majority of the video management software providers in the industry, as well as software providers that do all kinds of other, perform all kinds of other functions. So this is just a snapshot of some of our technology partnerships that are out there. We have certified and validated all of these. We have end-user deployments with the vast majority of these all around the world. I didn't talk too much about our company qualifications, but we have been in business, as I mentioned, since 2003. We're deployed in over 53 countries around the world. You'll see that from a video surveillance standpoint, some of the largest and most sophisticated video implementations in the world are deployed on the back of Pivot 3 infrastructure. Now, the one thing I'll point out about, and this is just a snapshot of a couple of our more prominent end users out there, but one thing I'll point out about these is that across all of our end users, there's one common theme across them all, and that is that they do not have, or they cannot tolerate downtime or data loss. And that's really what we protect against. Virtually all video systems have some level of scalability requirements, which we do in a very, very efficient way. But you'll find some variability in organizations that can tolerate downtime or data loss. Now, as video, as we mentioned before, is becoming more and more important and more critical to us, the ability to tolerate that downtime and data loss is really almost diminishing or almost disappearing. Okay, so the common theme across these is no tolerance for downtime or data loss. Now, some people would also look at these and say, Pivot 3 is really only a fit for the big, complex, hundreds, if not thousands of cameras types of systems. And while I will say that we are a very good fit for big, complex, hundreds or thousands of camera systems, we're also a very good fit for smaller systems. In fact, in the last year, I don't have the list of our products on here, but we'd be happy to go over those with you. In the last year or so, we've come out with a solution called the Edge Protect that is designed to bring all of that same capability, all of the performance, the resiliency, the scalability, and bring that to systems that are smaller, that are less than 100 cameras, less than 50 cameras or so, and do so in a way that's very, very cost effective, comparable in price to NVRs and direct attached storage. So companies like FedEx Ground have deployed solutions like that in over 600 of their facilities around the United States that have typically less than 100 cameras in each one of them. But they're leveraging our technology to deliver the value and the functionality that we deliver, which is eliminating downtime, eliminating data loss, maximizing scalability, and maximizing performance. Okay. That being said, that's all I have today. So I think I'll open it up, Jenny, here and see if we have any questions. I don't see any on my side, but do we have any questions out there?
I don't see any on my side
either. We have any questions out there right now. If you do have a question, please enter it in here. What I will offer, though, is that we'd be happy to have a follow-up conversation with you following this presentation today. We'll be happy to go into more depth anywhere. We can go into a little more detail around how we deliver some of these things. Of course, explain our technology in more detail. And what we like to do is really understand your environment and understand what your challenges are, and then really tailor our solutions to be sure that we're helping you solve your problems. Okay, well, with that being said, if there's no questions, I guess we'll end the session here now. Thank you, everybody, for taking the time today. Feel free to reach out to me. We'll be sure that everyone has a copy of these slides and everyone's contact information, but feel free to reach out to us if you have any additional questions. Thank you very much.